In this video, we'll find the equation of motion in an inverse square attractive force field. Here the central force is inverse square attractive one. So it's given by like f of r equals to minus k by r square, where k greater than 0. Okay. Now the differential equation of motion of a particle under central force field is given by due to u d theta 2 plus u equals to minus f of r by m h square u square. Okay, now we have to put the value of f of r, that is minus k by r square. So putting the value of f of r, we get k by r square into 1 by m h square u square. Since we have considered that u equals to 1 by r, so this r square and u square will be cancelled and remaining k by m h square. Okay, sorry. Now from this we get d2 d theta 2 plus u minus k by m h square equals to 0. That is equation number 1. Now we consider that this term u minus k by m h square is equal to a new quantity, that is capital U. Now differentiating on both sides with respect to theta 2 times, we get d2 d theta 2 equals to d2 capital U d theta 2, because this term is constant. Okay, so from this equation number 1 we get d2 capital U d theta 2 plus it have the value capital U equals to 0. Now this equation have the solution like u equals to a cosine theta plus b sin theta. Now we consider that value of a, that's equals to c cosine phi, and value of v is equals to c sin phi. Now putting the value of a and b, in that case we get c cosine phi cosine theta plus c sin theta sin phi. That's equals to, taken c common, we get c cos theta cos phi plus sin theta sin phi, and this can be written as c of cosine theta minus phi. Okay, now we have get capital U. Now from this we can get small u, that is equals to u plus k by m h square, and put the value of capital U, that is c cosine theta minus phi plus k by m square. Now a proper choice of axis leads to phi equals to 0. So we get u, that's equals to c cosine theta plus k by m h square. Okay, and since we take that r equals to 1 by u, so r equals to 1 by value of u, that is c cosine theta plus k by m h square. Now multiplying all the terms with m h square by k, we get that is m h square by k divided by m h square by k into c cosine theta plus 1. Now we take this m h square by k term as L and this m h square by k into c term as epsilon. So this equation becomes r equal to L by epsilon cos theta plus 1, and this is the equation of a conic section where L is the semilatus rectum and epsilon is the eccentricity of the orbit.